Okay, so now we want to talk about what happens if we have equations on both sides. Not equations, variables. Remember that the number one goal when you're solving an equation is to isolate the variable. So this means that you only have one variable and it has to stand alone. It has to be isolated. Sometimes that takes a lot of work and a lot of steps. Remember the steps to solve, and in this case they are the same that they were for multi-step equations, because essentially this is just a big multi-step equation. First step, use your distributive property if you need to. Second step, clear the equation of any fractions if you need to. Third step, this is the big one, get all your variables on one side, get all your numbers on one side. Go ahead and separate them for the easiest means possible. And then the fourth step, most important, isolate the variable. And to do this, I'm combining the last steps from the last video. Undo all your addition and subtraction, undo all your multiplication. You're peeling away layers of an onion until you have your variable all by itself, because that is your goal when you're solving an equation. Whether it's a 1-step or a 22-step, your goal is to get the variable alone. I promise not to give you any 22-step equations. Not this year. Alright, so let's do some examples. So here we have 6x minus 2 equals x plus 13. So when you're doing an equation with variables on both sides, regardless of which side the x is on, the x is the same value. So what we're looking for is what value of x can we have that whether I put it here or here, it's going to solve the same way. That is why we can shift everything around, put the x's together on one side, and solve it. So in this case, I'm going to take my x to this side, because if I subtract x from 6 over here, it gives me 5x, where if I subtract x here, it gives me negative 5x, and then I'm dealing with negatives on this side, and I don't want to. So I'm going to subtract x from here, subtract x from here, so that's going to give me 5x minus 2 equals 13. Okay, so I took care of one part. I got my variable on one side, but I still have a number. So now I get this. So now I have 5x equals 15. Okay, so I'm getting closer. I have variables on one side, I have numbers on one side. Last step, undo it. Divide by 5, divide by 5. I'm left with x equal to 3. So what if I plug it back in and do 6 times 3 minus 2? That gives me 18 minus 2, or 17, or 16, go Miss Ernest. And then over here, if I put 3 plus 13, that also gives me 16, and 16 equals 16, so we've been successful. Okay, let's look at number 2. 8 plus x equals 2x minus 1. Okay, again, remember, when you start shifting your variables, you want to try and get a positive variable. Won't always work, but in this case it will. So minus x, minus x. So on this side I just get x. Still have 8, minus 1. So now I've got my variables on this side, so this is going to come over here. Plus 1, plus 1. So here I get 9, over here I get x, and I'm done. So x equals 9. Well, does that work up here? 8 plus 9 gives me 17. 2 times 9 is 18. Minus 1, 17. Voila! 17 equals 17. We're done. Alright, so let's get a little more complicated. Those were easy. 4p minus 10 on this side. Over here, p plus 3p plus 2p. So before I can start moving variables back and forth, I've got to combine some like terms. So p plus 3p, that's 4p, minus 2p, that's 2p. So now I'm going to rewrite my equation like this. So I have this. So now this time, since all I have over here is a variable, I'm just going to shift my 4p over this way. So now I am going to end up with a negative, but that's okay. So I'm going to have negative 10 equals negative 2p. So that's all right. Remember, when you're solving equations, your variable not only has to be alone, but it has to be positive. So I need to make sure that I divide not only by 2, but by -2 so that my p becomes a positive. So my p is going to equal 5. Oh, well, this should be fun to solve. So I'm going to do 4 times 5, which is 20 minus 10. So on this side I get 10. Now over here, I'm going to have 5 plus 15 minus 10. So 20 minus 10. So over here I also got 10. Everything works. Okay, so one more. Got the distributive property this time. So before I can combine, got to distribute. So 4 times x, I'm going to write my 6x, just bring that on down. 4x plus 20. Now, combine my like terms. So I have no whole numbers over here. I'm just going to bring this over. Subtract my 4x from both sides. So over here I get 2x equals 20. Okay, so all my variables are on one side, all my whole numbers are on the other. No need to do any more adding or subtracting, so I'm just going to divide. Divided by 2, divided by 2, I learned that x equals 10. And if we plugged it back in, 6 times 10 gives me 60. 4 times 10 is 40, plus 20, 60 equals 60. Everything equals out. So we solved all 4 of these, and in every one of them we found x values that plugged in on either side of the equal sign. They were the same.